Most of us think we understand light well enough. It turns on a room, warms our skin, lets us see. We learn early that it moves very fast, faster than anything else we know. So fast that in everyday life it might as well be instant. This makes light feel simple, familiar, harmless, just another thing moving through space, only quicker than the rest. That assumption is the comforting lie. We picture space as an empty stage, and light as an actor crossing it at tremendous speed, like a bullet, or a wave, or a stream of particles rushing forward. If it moves faster, we imagine it simply covers more distance in less time. Nothing about that picture feels threatening. It fits neatly with how we experience motion in daily life. But this picture hides a quiet problem. Every other moving thing obeys the same basic rule. How fast it moves depends on how fast you are moving. Walk forward on a train and your speed adds to the train's speed. Throw a ball from a moving car and it carries that motion with it. Movement is relative. Speed depends on who is doing the measuring. This rule works everywhere, for everything we normally encounter. Light, however, refuses to play along. Long before anyone understood why, experiments began to hint that light does not behave like other moving things. Its speed seems stubbornly fixed, immune to the motion of its source or its observer. At first this was easy to ignore. The numbers were extreme, the effects subtle. Everyday intuition survived unchallenged. So we kept the simple picture: light as a fast object, space as a passive container, time as a universal clock ticking the same for everyone. Together, these ideas form a worldview that feels natural and deeply reassuring. Reality behaves the way our instincts say it should. The universe is strange in places, perhaps, but not fundamentally hostile to common sense. The unsettling part is that this worldview only survives because we rarely push it. The moment we ask precise questions, the picture begins to crack. What exactly does it mean for light to move? Compared to what? Measured by whom? These are not philosophical games. They are practical questions. And when physicists tried to answer them carefully, the answers refused to line up. Light does not simply travel through space. Its behavior forces us to confront the possibility that space itself is not what we think it is, that time may not flow the way it feels, that motion at a deep level obeys rules that are nothing like the ones we grew up with. The speed of light is not just impressive, it is a warning sign. At first, this warning is easy to miss. Nothing explodes. No laws are visibly broken. The universe continues to look ordinary. But beneath that calm surface, something is already wrong. And once you notice it, you cannot unsee it. The simple, comforting story about light begins to unravel, pulling space and time along with it. This is where the story truly begins. Not with equations or experiments, but with the quiet realization that something ordinary has been hiding a much deeper disturbance in plain sight all along, for far longer than expected. Once the comforting picture of light as just another fast-moving thing begins to crack, the next step is unavoidable: measurement. Physics does not argue with intuition by philosophy alone. It forces intuition to face numbers, clocks, distances, and results that either agree or refuse to cooperate. And when it comes to light, measurement is where cooperation completely breaks down. In everyday life, measuring speed is straightforward. You measure how far something travels and how long it takes. If you are moving while you do this, your motion matters. Stand still and watch a car pass by, and you get one speed. Drive alongside it, and the speed changes. This is so obvious that we rarely notice it as an assumption. Speed depends on perspective. Motion is relative. This idea is stitched into common sense itself. So imagine performing this same measurement on light. Shine a beam, measure the distance it travels, divide by the time it takes. Now repeat the experiment while moving. According to everything we know about motion, the result should change. If you chase the light, it should appear slower. If you move toward it, it should appear faster. Nothing in ordinary experience suggests otherwise. Yet every careful experiment stubbornly returns the same result. No matter how the source moves, no matter how the observer moves, the measured speed of light refuses to change. Not approximately, not on average, exactly. This is not a rounding error or a limitation of instruments. The numbers line up with unsettling precision. At first, this seems almost trivial. Light is very fast, after all. Perhaps the differences are simply too small to notice. But the experiments were designed specifically to detect those differences, and they did not fail quietly. They failed decisively. Again and again, motion that should have mattered did not. This is the moment where intuition truly runs out of excuses. If speeds always add, and light's speed does not add, then light is not behaving like a thing moving through space in the usual sense. Something deeper is happening. Either our understanding of motion is wrong, or our understanding of space is incomplete, or both. What makes this especially unsettling is how universal the effect is. There is no special frame of reference where light behaves normally, no hidden state of rest you can appeal to. Every observer, no matter how they move, measures the same speed. The universe offers no preferred viewpoint, no absolute background against which motion is defined. This refusal of measurement to make sense is not dramatic on the surface. There is no sudden catastrophe, no visual paradox, just a quiet mismatch between expectation and result. But that mismatch is enough to destabilize everything built on top of it. If measurement itself cannot be trusted to behave intuitively, then the structures we rely on to describe reality are already compromised. This is why the problem lingered for so long. Nothing seemed broken enough to demand immediate repair. Engineers could still build machines. Astronomers could still predict motions. Daily life carried on without protest. Yet underneath that practical success sat a contradiction that refused to go away. A speed that stayed the same no matter how it was measured was not a small anomaly. It was a direct challenge to how measurement itself was supposed to work, quietly insisting that something fundamental had been misunderstood from the beginning, in subtle ways globally. At this stage, the mystery has sharpened. Light is no longer merely strange. It is actively undermining the rules we use to describe motion. The problem is no longer about light alone. It is about the framework within which all motion is understood. And once that framework is in question, there is only one place left to look for the explanation: the nature of space and time themselves, which until now have quietly escaped scrutiny. By the time we reach this point, it is tempting to blame light itself. It feels natural to assume that light must have some strange internal property, some hidden trick that makes it behave differently from everything else. But this instinct turns out to be backwards. The deeper problem is not light. The deeper problem is the stage on which light appears to move. We grow up with the idea that space and time are fixed. Space is the three-dimensional arena where things exist. Time is the invisible current that carries events forward. They feel absolute, universal, the same for everyone. Objects move through space, clocks tick through time, and the two seem independent. This separation feels so obvious that questioning it seems unnecessary. Yet the stubborn behavior of light forces that question. If every observer measures the same speed for light, something has to give. Either measurements are lying or the framework we use to interpret them is incomplete. The resolution, unsettling as it is, points directly at space and time themselves. They are not passive backgrounds. They are active participants. When an observer moves, the universe does not allow the speed of light to change. Instead, it quietly reshuffles how distance and duration are measured. Lengths contract in the direction of motion. Clocks tick more slowly. These are not perceptual tricks or errors of instrumentation. They are real, physical changes that depend on motion. The faster you move, the more pronounced they become. This is the moment where reality starts to feel uncomfortably flexible. Space is no longer a rigid container. Time is no longer a universal flow. They respond to motion, bending just enough to preserve the one thing that refuses to change. Light remains constant because space and time absorb the difference. What makes this especially difficult to accept is how well hidden it is. At ordinary speeds, the effects are tiny. Our bodies, our machines, and our daily experiences are all confined to a narrow range where space and time appear solid and dependable. Nothing in everyday life prepares us for the idea that they can stretch and compress. But the mathematics does not allow alternatives. If the speed of light is to be the same for everyone, then distances and durations cannot be the same for everyone. There is no compromise solution. The universe chooses consistency over comfort, even if that consistency undermines our intuition. The unsettling implication is that motion through space and motion through time are not separate things. They are different aspects of a single movement through a combined structure. When you move faster through space, you inevitably move more slowly through time. Your experience of duration changes because the geometry of reality demands it. This reframing turns familiar concepts inside out. Time dilation is not a glitch. Length contraction is not a technical detail. They are the visible symptoms of a deeper arrangement. one in which space and time are woven together so tightly that altering one forces the other to respond. Seen this way, light is no longer the star of the story. It is the messenger. Its unchanging speed exposes the hidden rules governing the structure of reality. Light does not force space and time to change. It reveals that they were never fixed to begin with. This realization carries a quiet unease. If space and time can rearrange themselves, then the world we navigate is less solid than it appears. The floor does not give way beneath us, but the foundations of our understanding do. What we thought were permanent features turn out to be relational, dependent on motion and perspective. The universe is not correcting a mistake when it slows clocks and shrinks distances. It is expressing its true design. Space and time were always flexible. We simply lack the conditions to notice. Light provides those conditions by insisting on its constancy. By protecting the speed of light, reality reveals something far more disturbing than a fast beam crossing empty space. It reveals that space and time are dynamic, adaptable, and deeply interconnected. The familiar world survives only because these changes remain subtle at human scales. Once this is understood, the mystery shifts again. The question is no longer why light behaves so strangely. The question becomes why reality is structured in a way that demands such behavior in the first place. That question leads directly toward a deeper limit embedded within reality itself. Waiting ahead now. The idea of a speed limit sounds familiar. We encounter limits everywhere. Roads have maximum speeds, machines have tolerances, bodies have breaking points. So when we hear that the universe has a maximum speed, it is easy to imagine it as just another rule, imposed from above, something written into the laws of physics, like a warning sign. Do not go faster than this. But this intuition is misleading. The speed of light is not a restriction placed on motion in the way a rule restricts behavior. Nothing is being actively stopped. No invisible force pushes back when something tries to exceed it. Instead, the limit emerges from how reality itself is constructed. It is not enforced, it is revealed. To understand this, it helps to stop thinking in terms of objects racing through space and start thinking in terms of cause and effect. Whenever something happens, it influences something else. A signal is sent, an effect follows a cause. Physics is, at its core, a description of how these influences propagate through the universe. The speed of light marks the maximum rate at which this propagation can occur. This is why faster-than-light motion is not forbidden in the usual sense. It is meaningless. To move faster than light would require an effect to appear before its cause, or information to arrive before it was sent. That is not a technical problem, it is a logical one. Cause and effect would lose their order, and with it the very idea of an event. Seen this way, the speed of light is not about light at all. Light simply travels at this maximum rate because it has no mass. It follows the natural pathways laid out by space-time's geometry. Massive objects move more slowly through these pathways because their motion is divided between space and time. They cannot allocate all of it to space without violating the structure they inhabit. As an object accelerates, this division becomes more extreme. More of its motion is spent moving through space, leaving less available for motion through time. The closer it gets to the speed of light, the less time it has left to give. Pushing further does not make it go faster in any meaningful sense. It only increases the resistance to change, because there is no remaining structure to support additional spatial motion. This is why no amount of energy can carry a massive object to the speed of light. The obstacle is not weakness of engines or limits of technology. It is that space-time itself offers no configuration in which such motion can exist. The limit is not a wall at the edge of the universe. It is a property of the universe's internal architecture. What makes this unsettling is how impersonal it is. There is no purpose behind the limit, no intention, no reason in the everyday sense. The universe is not trying to protect itself or enforce order. It simply has a shape, and that shape permits some motions and not others. The speed of light is the clearest expression of that shape. It defines the boundary between what can influence what. It determines which events can be connected and which must remain forever separate. It carves reality into regions of possibility and impossibility, not by decree but by geometry. Once this is understood, the mystery deepens again. If this limit arises from the structure of space-time, then light is only a guide pointing towards something more fundamental. The unsettling behavior of light is not the root of the problem, it is the symptom. And what it points to is a universe where the deepest rules are not imposed from outside, but emerge quietly from the way reality is built. This realization replaces the idea of cosmic speed enforcement with something colder, a universe whose limits arise automatically, indifferent to intention, expectation, desire, or human intuition itself. Light often feels like the hero of the story, but by the end of this journey it becomes clear that it is really a messenger. It does not create the strangeness we have been tracing. It reveals it. By insisting on a constant speed, light exposes the hidden framework that governs how reality allows events to happen at all. What light ultimately shows us is that the universe is not built around objects, but around relationships. Space is not merely where things are, and time is not merely when they happen. Together they form a structure that determines which events can influence one another and which cannot. Light traces the edges of that structure, making its limits visible. This is why the behavior of light feels unsettling, rather than merely surprising. It forces us to abandon the idea of a single universal present. Different observers do not just see events differently. They live within different slices of time, each shaped by motion. The universe does not provide one shared now. It provides a consistent rule that replaces it. From this perspective, understanding light is not about mastering a physical phenomenon. It is about learning how reality organizes cause and effect. The speed of light sets the scale at which change can propagate. It defines how quickly the universe can update itself. Every interaction, every force, every signal is constrained by this same underlying rhythm. This realization carries a quiet humility. Human intuition evolved in a world where these effects were invisible. Our senses are tuned to speeds and distances, where space and time appear rigid and absolute. The deeper structure remained hidden, not because it was subtle, but because we were never moving fast enough to notice. Yet once revealed, it cannot be ignored. The constancy of light reshapes how we think about distance, duration, and connection. It tells us that separation is not just a matter of space, and delay is not just a matter of time. They are intertwined limits imposed by the geometry of space-time itself. What makes this understanding powerful is not that it closes the mystery, but that it reframes it. We stop asking why light is special and start asking what kind of universe makes such behavior inevitable. The answer is not a story of design or purpose, but of structure. Reality behaves the way it does because it cannot behave otherwise. This does not drain the universe of wonder. It deepens it. A cosmos governed by hidden geometric relationships is not cold or mechanical. It is subtle, coherent, and strangely elegant. The same rule that limits motion also allows stars to shine, atoms to hold together, and information to flow. Light becomes the thread that stitches these ideas together. By following it, we uncover not a final explanation, but a clearer view of how explanations themselves must work. Physics does not offer comfort or certainty. It offers understanding, and understanding often comes with unease. In the end, light does not tell us everything. It tells us enough to see that reality is not built the way we feel it is. Space and time are not the stage. They are part of the script. And by revealing this, light leaves us with a universe that is stranger than imagination, yet ordered enough to be known. That tension between strangeness and structure is the lasting lesson light leaves behind. Once you see this, every familiar scene carries a quiet question, asking not what you observe, but how the universe allows that observation to exist at all, within its invisible boundaries of space and time itself.